Automation, Modern Demand Forecasting. It will be led by Chandler McCann, GM Time Series data scientist at DataRobot. Chandler is a senior data scientist at DataRobot and leads the data science practice for the East Coast, where he works to help DataRobot's Fortune 50 clients to leverage automated machine learning. Chandler has helped some of the world's largest retailers apply automated machine learning to demand forecasting, helping them realize hundreds of millions of dollars in ROI. Chandler has over 15 years of experience in analytics and data science. He received his master's in information and data science from UC Berkeley and his undergraduate in materials science engineering from the University of Maryland. In addition to helping his customers achieve success in demand forecasting, Chandler leads DataRobot's Altruistic AI program and works with nonprofits and NGOs to harness the power of machine learning. There, he recently worked with the governments of Sierra Leone and Liberia to use machine learning to improve access to water across their countries. Please join me in welcoming Chandler McCann to the stage.
Okay, is this thing working? All right. Good morning, everyone. Thank you for that kind introduction. So, as you were saying, my name is Chandler McCann. I am a data scientist at DataRobot. I've been at DataRobot for about 2 years now, and I've really enjoyed my time there. I get the opportunity to work with customers across a wide range of industries and verticals, to include retail, and I've been fortunate enough to work with some of the largest global retailers on a really interesting use case that I think is really powerful, and I'm excited to share with you today, and that's demand forecasting. So a little bit about DataRobot, if you haven't heard of us. So DataRobot is an automated machine learning company that makes it really simple for data scientists and non-data scientists alike to build really accurate predictive models in a fraction of the time it used to take, deploy those models, and then monitor them over time, all without having to code. So we've been around since 2012. Our founders, Jeremy Aitchen and Tom Digadoy, were working in machine learning before AI was the sexiest buzzword around, and they were leading data science teams at Travelers Insurance in 2 different lines of business. But on the weekends, they would compete in Kaggle competitions. So if you aren't aware what Kaggle is sort of like the Olympics for data scientists online. And when it was first founded, companies could go and submit a problem to the global community, and people would compete for money. So whoever could come up with the most accurate model would win a prize. And Jeremy and Tom teamed up, and they did just that. But in the process of competing, they noticed that within the modeling process for data science, there's a lot of repetitive tasks. So they worked to automate some of those tasks in order to be more efficient. And they did that and saw some positive results. In addition, they also saw that working with domain experts on certain use cases, so for a healthcare use case, pulling in a data scientist with expertise in healthcare also helped a lot, right? So this idea of automation and domain expertise became really central to their approach to winning competitions. They used some of those winnings to bootstrap the company, and DataRobot was born. So fast forward to today, we've closed our Series D round and raised about $224 million in funding. But we spent the first 3 years of our time as a company just investing in R&D. And this was the first automated machine learning platform out there. So how do we build it correctly? So we spent about 3 years developing that. And in 2015, we released DataRobot to the world on our public cloud on AWS. Since then, though, we've built over 1 billion models on that cloud, and we're building about 2.5 million models per day right now. That's just our cloud. We have an enterprise version, so we assume a similar amount of models are being built out there for those customers, but we don't have tracking of that as easily. Now, we are a company of data scientists for data scientists. We've got about over 200 data scientists and engineers. Of our 600 employees, we've got about 300 openings right now online. We're growing rapidly, and our product has developed a lot. So since 2015, we've had 4 major releases to include our time series product release about 1.5 years ago. So one thing we do bring, though, is experience delivering thousands of successful AI projects. I think today it's pretty simple to build a machine learning model. I think it's harder to build a good one. It's even harder to deploy it, harder than that to monitor it well over time. But driving success with AI across an organization is actually a pretty tricky problem. And we've seen the spectrum of companies this week talking about that. And we have a pretty long resume addressing that issue. So I want to talk about how we can do that with demand forecasting today. So I mentioned a lot of buzzwords. It'd be good to level set on those before I get too far into this. And so I want to talk about some definitions. So when I say machine learning, we're just talking about learning from the past to predict the future, right? So we consider deep learning to be a subset of that. Think about your full motion video, your computer vision, certain aspects of NLP. And AI is simply systems that are able to perform tasks that ordinarily require human intelligence, and that's all that is. So you can imagine that these circles here represent a machine learning or models in your organization, and they can come in different flavors. The blue ones are machine learning models. Maybe you have 1 or 2 deep learning use cases deployed. A couple boring systems we call, old legacy rule-based systems, some logic-based systems. But all those work together to do one thing, and that's add value. And that comes in different flavors. So they're either going to be automating something, going to be optimizing something, or producing actionable insights. So because they add value, companies are really excited to get behind this. And obviously, we're all here at this conference. But the challenge, though, is that it's very difficult to scale your data science capabilities at a company. So, think about it. Is your demand for AI and machine learning in your space at your company going to grow or shrink over the next few years? It's going up. But the ability to meet that demand by hand coding models is challenging. So what do we do? How do we stay competitive in this space? Well, there's a couple options. One way is to try and hire an army of data scientists. The challenge there, though, is that data scientists are expensive. You see data scientists being listed as the sexiest job of 2018. So there's a lot of competition for that space. And also, if you're not geographically in the right area, it may be hard to hire those data scientists. And also, you're competing against some of the larger companies out there for that talent. So you could also pursue some vendor-based models, which are good, but those are point solutions typically. And if you're trying to be AI-driven, you have to buy a lot of those point solutions. And then, of course, there's consultants, also not classically the cheapest approach. So that's why we invented automated machine learning, to help bridge that gap. And particularly when you're looking at demand forecasting, there's a lot of opportunities to replicate this throughout your space. So with AutoML, we're seeing that companies are achieving AI success with their existing talent pool, right? So this can help in 2 ways. So, when you think of a data scientist, you think of someone that has computer science skills, statistics skills, which is usually roughly 2 master's degrees, and then domain knowledge. So your company has a lot of people with domain knowledge. Automated machine learning can help with those first 2, computer science and statistics. However, it's not a replacement for data scientists. It's a huge efficiency gain for the ones that you have employed right now. So I haven't met a data scientist that said, I don't have enough to do at my company. There's always a backlog out there, and we can help get through that more quickly. And that's the way that we're addressing this demand. But when I'm talking about automating machine learning, what are we talking about? So tongue-in-cheek, I like to describe data scientists as like artisans, right? Sort of like cigar rollers. We produce stuff that takes a long time to produce by hand. It's of extremely high value, but it's in short supply and it's expensive. And the reason is because there's a lot of steps to that process. If I want to build a model, I have to, first off, probably work with the business unit to understand what that problem is. I need to get the data, import it, do some engineering on the features, maybe think of ways to handle missing values, come up with, make that data machine readable. Then I've got to think about how I want to set up my experiment. I've got to think about how to make this model testable to ensure that it's going to perform well in the wild. After that, I've got to think about what algorithms I want to use to build that model. I've got to go and figure out which knobs to turn on that algorithm, which hyperparameters to tune. Then I rinse and repeat on this process for some time. If I'm lucky, then I can decide to go to deployment with that model. So I have to work with IT to integrate that into whatever application I have. From there, maybe I'm monitoring that effectively over time, and that could just be as simple as choosing to refresh it every few months. And then all that takes roughly 3 months if you have a really good team, usually, maybe 6. That's a slow process. Now, with automation, we can allow our domain experts to come in, bring their data, upload it, say, I would like to forecast this column, and we take care of the rest. So we can automate the feature engineering of that, build out the lags for your data set, for your time series models, test those competitively, try thousands of different combinations of feature engineering and algorithms, and then make it really easy to deploy those models and monitor them over time. That process takes hours or days. So being able to collapse that life cycle from roughly months to days or weeks is huge. That also raises some really interesting questions within retail, because there's a lot you can work on. There's hundreds of opportunities to optimize every line of business in your space using machine learning, but we tend to be myopic. We think about AI, and there's this one use case I can work on because it's typically taken forever to work on one of those. But with automation, we can start to address those more effectively. Now, I would encourage you to be AI-driven. You need to be integrating AI solutions throughout your business. But where do I start? And we propose that demand forecasting is a really good place to start because it's so central to every other aspect of your business. So thought experiment. If you can improve demand forecasting in your space 4 weeks out, 8 weeks out, 12, 24, whatever time period is relevant to you, by 50%, how would that change your business? How would that impact operations? How would that impact stocking? How would that impact staffing? It'd be huge. So moving the needle a little bit here has massive upstream and downstream benefits. So if I'm going to think about which of these use cases drive the most value, in our experience, the top right corner here is where we're going to see the biggest return. So staffing at our distribution and fulfillment centers, as well as staffing at stores. Those are fairly tractable problems. Usually have less fulfillment centers than you do stores. Capacity planning allocation, being able to predict every item in every store 2 weeks out. Super high value, that's a much harder problem. So it's good to get some muscle memory working on demand forecasting at those slightly more higher levels early on. Same with managing SKUs. So huge value in the top right corner, but how do we quantify that, right? So if I'm going to be working on time series models, how do I define that value? So time series models are going to generate value in one of two ways. So if I'm underestimating demand, that's going to lead to lost revenue by, for example, in a call center. If I underestimate the amount of calls, I'm understaffed, that leads to long wait times. Perhaps my customers are unhappy about that. If I'm understocking, there's obviously nothing to sell on the shelf. I could lose customers in that setting. On the other side, if I'm overestimating demand, then I'm essentially wasting resources when it comes to staffing. There's excess employee cost. Similarly, if I'm overstocking, then that leads to markdowns and excess inventory. But how do we get a little bit more granular when you're thinking about which projects to pursue in your business? So obviously think about accuracy, but I would encourage you to think about scale. So when I'm talking about accuracy, the first question you have to ask is just how is it performing? Is there room for improvement? We know our historical performance. We know what our historical actual demand. We also know what our predicted demand was at the time. And we want to see if there's any variability there for us to work on. If there is, we want to think about where is our current model or process missing? Are we having spikes intermittently that we seem to not be able to account for? Are we constantly missing our seasonal spikes? Are certain holidays always burning us? Those are good places to start. So thinking of a large retailer we worked with, they were using a simple Facebook profit algorithm with their data science team to forecast demand for Black Friday, working with them and adding in useful information from their marketing events, important calendar dates. We were able to, in 2 months, iterate on their model 50 times through automation. and get their demand forecasts 4 weeks out up from 65% accuracy to 95%. So that was a $2 million a week improvement for that one retailer. And that was the first model they put into production with us. So lots of opportunities to improve. The second question I'd ask is about scale. And this classically wasn't an easy problem for medium or small sized companies because it's hard to handle hundreds or thousands of models in production at the same time. But the larger the business process, the more valuable the accuracy improvement is going to be for your team, right? So if I can get a 10% lift and I only have one store, that's going to help a little bit. But if I've got 150 or 200, that's a huge difference. Working with another customer in fast retail, we were able to, this was every item, every store, level forecasting, get a 10% improvement. And at that size, the percentage improvement on your demand forecast is roughly equivalent to your percentage of revenue. So for them, that was $400 million annually improvement we're able to make. So looking for opportunities to scale is crucially important when you're trying to figure out which opportunity to work on. So let's walk through a simple example. So we're all probably familiar with fulfillment centers. They're operating on a planned schedule. But when demand spikes, you go into the situation of needing to hire very expensive contract labor. And when this happens over and over and over again, that cost just builds up. So how can we figure out the value of improving this process? So the first step is going to be to think about what's my ideal ratio of employee hours to orders, right? So we should know either historically from management experience, perhaps some testing, what that ideal ratio is. And then what's my forecast telling me? What's my anticipated demand going to be? That simple ratio is going to come up with an estimated number of employee hours. And if you're getting into more detailed workforce planning, you're probably familiar with this idea. So we have to start here. We have to figure out what our estimation is. And then from there, you're going to land in one of two zones. Either I'm going to be understaffed, which is going to result in hourly contract labor, or I'm going to be overstaffed, resulting in higher employee hourly costs. Now, you may be saying those prices aren't the same, which is obviously a true statement. So you could just sandbag it and say, I'm always going to overstaff with my employees, but that adds up over time, and that's a huge cost to take on. Similarly, you could say, well, I'm just going to let it ride and hire contract costs as it comes up. Same boat. It's still expensive. So it's this constant balancing act. And the only way you're going to get to any kind of reasonable operational efficiency is through improving the accuracy of your demand forecast. So by doing so, that's going to allow you to achieve that balance between under and overstaffing a lot more reasonably and generate improvements from cost avoidance, right? So you're going to dial in that ratio of contract labor to excess employee costs. Now, I'd also challenge you to think about what are the second order benefits from customer satisfaction that this drives in my business? So reduced delivery times, on-time deliveries, those all matter, and that's all byproduct of improved demand forecasting. So as I mentioned before, we just walked through one simple example of how we can apply demand forecasting to improve value. But as I mentioned, there are hundreds of use cases in your business. And it's really simple to fall into this trap of thinking of, I've got a handful of AI projects. Like, think bigger. It's really across every aspect of your business. And when you enable your data science team and your business analysts, we call them capable and motivated business analysts, to leverage AI, you're going to unlock a ton of value. But as you're going on this journey, even if you're really far down, I encourage you to try to go about it systematically and think about, where can I get some good muscle memory from learning to do these use cases? So I think staffing optimization, again, at fulfillment centers is a great entry point. It's fairly tractable. Staffing at stores, same deal. It's also very tractable to get after. And then from there, you're going to get that muscle memory to start to address the every item, every store, every few weeks. That's a complicated use case because some of these items, as you know, will have different time periods and different histories. So to actually manage all the models required to support that, it takes a little bit extra work. But if you go down that path, we'd be happy to join you on that. And I'll be at the booth all day if anyone has any more detailed questions about applying demand forecasting in their business. So thank you. That's all I have for today.
Thank you so much. Please sit tight as we get ready for our first panel of the day, which will be joining me on stage in just a minute, okay?